Hello. Hello everyone. Let's start with an idea of machine learning. See, you should know what's a machine and what is learning. This repository will have some idea about the machine learning and a very few and a basic example how it is implemented in Python. But before that, I would like to say you what is the agenda of this. Today we'll learn what is the definition of machine learning and why it is a buzz nowadays. Why not few years back? What are the prerequisites, that is what things you should know before studying machine learning? What are the applications of machine learning? The learning process, that means what is the flow diagram of machine learning? What is the number of steps that you need to follow before the input and the output? And the types of machine learning, that is the supervised, unsupervised, and what are the further classification. Then are the algorithms. I'll just start with the basic idea of algorithms. What is regression, what is classification and the clustering. Later with each, there are different types of techniques with the algos. I'll proceed on with a different video and a very small implementation in Python. I'll just try to have what a linear regression does and what all you can do with it. Let's start with what is machine learning. If you see the definition of machine learning, it is like it's a computer program which learns from its own experience to perform a specific task. See, this is like an official definition. Now if I want to explain you, for example, there is a child who just watches you to walk, and after few years or few months the child learns walking. That means just by the feedback, that is, he is watching you, he is memorizing the pattern, how their parents are walking, and then the child starts walking. This is called machine learning, if the child is a machine. So you have to make the machine learn in such a way that it just watches you, stores the pattern, duplicates the pattern and gives you the same result as you were doing it emotionally. Just see the other definition. Machine learning is an application of artificial intelligence that provides system the ability to automatically learn from the data. What is the data? Data is the observations, the examples, the direct experiment. Like the example which I gave you, the walking of a child. For that particular child, the data is that you are walking. It is feeding it inside his brain, and that is the data for him. So you have to make the machine learn without intervention of any human being. So the machine learns, the machine gives the answers. The total process between it is the machine learning. Okay? Just see the official definition. A computer program is said to learn from experience E with respect to some class of task T and the performance measure P. You can say T is the prediction, experience E is the historical data to improve the task, and the measure of performance P is the accuracy. Like for example, how accurate the child is walking when he or she watches you walking. Now, if I take a simple example of Facebook, you know how to tag people. You see, initially it used to ask you to tag people. For example, it wants to tag me, I'll say yes, tagging Parmita Biswas. But nowadays, just seeing the face, it gives you option. You want to tag so and so and a 5 list of people. And the first person who you can see is tagging, it is the person who the computer recognizes and gives the maximum probability or the maximum chances of being that person. This is all a normal face recognition task which is done with the help of artificial intelligence, that is deep learning, machine learning. Like deep learning is also a part of machine learning. With the advancement of the video, I'll explain that too. See, you will be wondering why the machine learning is buzz nowadays. In the olden times, old is like 2000 or 2010, till that time you had social media like Orkut, and then came the Facebook. Much of other social sites were not there. But today with the help of Facebook, Twitter, Instagram, and many other social websites, you generate a lot of data every day. There such a great population. If each person is just sending a single like every day, you can just imagine how much data you are generating. Hence, till the time we are today, we have generated a lot of data. And for machine learning, the main prerequisite is data. We are having the data, and that is why we can play with the different algorithms and we can train the machines. Secondly, with time, the cost of the storage has decreased a lot. Initially, there was no such devices which could efficiently store such a huge amount of data that has been created. And thirdly, we are having many powerful libraries which made the life easier, especially in the terms of a developer or the programmer, so that we are using these libraries and then making our own assumptions and then the predictions. If you just see how the storage cost has changed with time, I have given some values, like just see the value in 1981 and then see the value in 2010. A simple storage has decreased a lot. So, time and money both are equally important. Not only time has decreased, for example, if it took near about 1 hour to process 1 GB of data, today it will take 1 minute. Therefore, this has been total decrease or squashing of time. And if you talk about memory, if you had to need a huge amount of memory like RAM or ROM for the processors, now we are needing it less. And as the cost have decreased a lot, the compactness has increased, due to which the space has also decreased. So these are the various factors why machine learning is being implemented like anything today. Everything can be converted into an artificial intelligence firm. It is just about the idea that you have to strike. See, I have already discussed the prerequisite is the data. You need lots and lots of data just to train a model. The machine needs the data, but what do you need? You need a little bit experience of computer, basic of database, stats and maths, and programming skills. Being a developer, you need these three things, and being a machine, it needs data, and data. And how you will use the data, how to manipulate the data, how you will make the machine learn, this is all the developer perspective. I hope you people have the basic idea of Python, because in Python only I'm going to implement the different types of algos, not exactly in this video but the further videos. So you can go through other Python tutorials so that a little bit idea of Python you can get. Next is the flow diagram of machine learning, that is how the machine learning works. See, there are various steps. I have defined it stepwise. The further is that you are having the raw data. Raw data, from where do you get this raw data? IoT, that is Internet of Things. It may be in the form of text, it may be images, it may be audio, it may be numbers. Data from the sensors. For example, there is a camera. The camera is capturing some image. This is a data. You are on Facebook. You are liking or sharing some material. This is a data. You have some criticism on a particular topic that is going on in your country and you write about it. That is a data. I want to know what kind of problems is a particular country facing. So I can just go on the Twitter or the Facebook, that what people are sharing there. So what is the hot topic going on there? These are all my raw data. Then comes the data engineering. This includes the data extraction. Now you know the Facebook have lots and lots of data, but you need to extract the data. You need the data in your own form. You cannot direct process those comments and likes. You need the clean data. For example, you have some problem statement and the data is having n number of features and you do not need it. Your data should be clean. It should be in a proper format so that it can be processed in terms of the programmer. Data normalization, data transformation, feature extraction. These are all the part of data engineering. Then you have to create the model. Model means you will be using different algos, or you will develop your own algo and then fit your particular model fit your particular data into that model. Then your model will be trained, then the model will be tested. Like, you'll have your testing set, you will find the performance, you'll find the accuracy, how your model is performing, how good your model is, what is the probability that your model will always give the right answer, and so on. And finally, you set your model live. Now, let's come into the real world examples. These are retail, e-commerce, healthcare, finance, travel, and media. Now, if I just think about retail or e-commerce, the first example which I get in my mind is the Amazon. You know, there is the recommendation engine of Amazon. It produces a lot of revenue for Amazon. The recommendation engine is totally one of the examples of machine learning. If you talk about the finance part, the stock market is going on, there are certain algos which are used by these people just to predict how your stock market will perform. For example, if you say travel, you must be knowing about the travel things like that of Uber. It has certain algos which finds the best route between the place A and place B and then suggests the driver to follow that particular path. Though the various factor on which that may depend is like the traffic, the minimum distance between the two, the traffic between the two, number of signals between the two, and so on. Now let's come to the topic of types of machine learning. The broader classification of machine learning is supervised and unsupervised learning. Supervised machine learning is a type of machine learning where you have the answer in your own data set. That means, for example, your data set is having a number of columns, and you want to know whether your child will come first, second, or what will be your rank in the next class. You will take the data of the last previous years and see the rank column, rank 1, rank 2, 4, 10, 20, anything. So you are going to predict the rank of your child based on the ranks of the last different years performance. This type of thing is called supervised learning. And this next is the unsupervised learning, where you don't know what is the exact output. You just want to make some pattern. You recognize the pattern and then group it as per your findings of that particular algo. Supervised are the examples of, or the further classification of supervised is the classification and regression. Unsupervised is association and clustering. Now let's see what are these. First is the regression problem. If the data involves in predicting the continuous or the quantitative output, we use the regression problem. For example, I have given two graphs. First is the house price prediction. There are various features how the price of the house is predicted, like the area where the house is, what is the size of the house, what is the number of bedrooms, number of bathrooms, population of that particular area, living standard of that particular area, and many things. I have tried to just take a single feature and then plot a graph. That is the price and the size of the house. And I get some particular points. This is the scatter plot graph. Based on this graph and the line which best fits this curve, we can predict the next price of the house. This is a regression problem because we are dealing with the exact price, that is the continuous variable. The second one is also again the square footage graph of size of single family homes, and it is again predicting the size of the house. So again it comes into numbers. Next is the classification. This involves where you have to category between two things or three things or n number of things. You already have a data which is categorized into two things. For example, you are classifying two clusters into a group who is having an income less than $50,000 and a group who is having the class of greater than $50,000. Therefore, there will be two classes, less than 50,000 and greater than 50,000, and you are classifying between the two. For example, I have seen the first graph. There are A and B. In the graph A, you can see we can have a single straight line which is just classifying between the two clusters or the two groups. And in the second one, the line is different. So there are different algos where you have to find this best fitted line where you can classify the two different groups. Where there are three groups, the problem statement becomes more complex, and you can see the next graph also. Then is the clustering. Cluster analysis or the clustering is the task of grouping the object in such a way that objects of the same groups are called a cluster are more similar. See, the difference between classification and clustering is that clustering is an unsupervised method. You didn't have this thing in a particular data set. Just based on certain patterns, you are just differentiating them and putting it into different clusters. You can see the graph and then can get a little bit of imagination about it. In the further videos, we'll go with the different other algos, how we are defining clusters and how we are implementing it. Now, what are the various algos that are there? That is, I have differentiated on the basis of unsupervised continuous, supervised continuous, unsupervised categorical, supervised categorical. So the different algos are clustering and dimensional reduction, SVD, PCA, that is principal component analysis, K-means, and the supervised comes linear regression, polynomial regression, decision trees, random forest. For the categorical one comes the a priori association analysis, that is, and the HMM, that is the hidden Markov model. And for the supervised, it is KNN, trees, logistic, naive Bayes, SVM. So we'll go with the different examples and the implementation of algos further in Python and conceptually both. First, we'll discuss what is the concept and manually solve the problem, and then we'll implement it in Python. Now, let's see how you can master what is the path where you to learn the machine learning. It is learn the data analytics. It is implemented in Python and R. Then the machine learning core, that is the machine learning and stats, supervised and unsupervised algos. And then is the visualization of the data. It can be done in Tableau, D3, ClickView. The basics you should know is like exploratory data analysis, stats, data insight, storytelling, and the basics of Python. You should know the definition of these and how are these done, because firstly you have to see the data, conceptually understand it, and then only move on the algo. You cannot blindly just apply any algo on this. Sorry. Now, I have taken a simple example of a pizza. You have to predict what is the price of the pizza based on the diameter. There are many pizza which is already in the market. I have taken two variables, x and y. One gives us the diameter and other the price. For example, we have the diameter as 6, 8, 10, 14, 18 and the prices as 7, 9, 13, 17.5 and 18. Firstly, I just want to plot this particular data in my graph. I am plotting this and then it comes that is the price in dollar versus diameter in inches, and I get this particular graph. Now if a particular person says me, now I am having a pizza who is having a size of 16, 17, what may be the price? I can have a best fitted line and then can predict what would be. Now what I have done, let's see, the machine learning library that we are using is the sklearn library. We are importing the linear regression algo, applying the linear model. What is exactly and mathematical formation I'll cover in the next video. Here I just want to show how exactly Python helps you in predicting things. I have taken, now I'm having my data, that is x and y. Now I want to predict the model where the diameter of the pizza is 12. I have printed it and predicted it for 12, and the model gives me the price as 13.68. Hence, a pizza which is still not in the market we have predicted the price of it as per the old data that they have given me. Now, you have predicted this. Now, you must be knowing whenever we are using the linear regression, there are certain errors. Just see, in this particular graph, this cannot be fitted in a straight line. But as we are importing linear regression, we are trying to fit a straight line, that is, which is having the equation y is equal to mx plus c with this. Therefore, each and every point will not be in the line. There would be some difference between them. This difference is the error, and this actually, the less the error, the more the accurate. Therefore, there is a certain function, that is the r squared function, which actually measures the error, and we are seeing how much accurate our system is. It says that our system is 66% accurate. What are the different measures of accuracy? What is the cost function? What is the error? These all I'll discuss in the other videos. This is just give you a simple idea how Python implementation is done. Now, let's see. Now we were just imagining our x is depending, that is our x is only the diameter. What if we are having some number of toppings? Therefore, it may be a combination of the diameter and toppings. So, x has two things. Similarly, we have created an x, just see, which is having two variables, 6, 2, 8, 1, 10, 0, 14, 2, 18, 0. Now, we are having the price as x. We are again calling the linear regression function, making a model, fitting our data into it, and then trying to predict a model which is predict for every value of x test. Now, just see, in the output you can see what is the difference between the predicted value and the target value. We already have our actual values. Based on it, we can see the difference between the predicted value and the target value. This difference is actually the error. We have to make the model in such a way that the error between these are minimum. So this was the simplest idea how a linear regression is implemented on a very simple data set. Here I have not gone through each and every point like that of taking the data, reading a CSV, dividing the data into train set, test set, training on the test set, comparing within the training on the training set, then comparing it with the test set, then seeing the accuracy on the test set, what is overfitting, underfitting, these all I'll be covering in the next topic. But this actually gives you an idea of Python implementation of a normal, very simple prediction problem. There are references in the books that you may refer for stats. I've given in the links. Also the code which I have used for the predicting the price of the salary, I've given the link. I've uploaded in the GitHub the same link. If you go to the last that I have covered for the stats, you can see from there also. Any type of doubt, do comment so that we can chat there or discuss there. And also, if you like our videos, don't hesitate to click on the like button. Do subscribe and keep on stay tuned. We'll have more videos. Thank you.